So we hear a lot of buzz around GenAI and a lot of people think it's overhyped. What's your take?
It's generative AI, so the final say is always humans. So there are human labelers, which will basically rate the quality of different audio samples. With the Playday app, which is this kind of generative AI version of Instagram, we built a stable diffusion. So we could basically teach stable diffusion what users looked like. There's the scientist researcher, the machine learning engineer, and then the ML ops or DevOps type person. And by default, there should be probably a pretty even distribution of those, but depending on the business needs, you might want to focus on one over the other.
Hello everyone, welcome to the Data Scientist Show. Today we have Erik Gafni. Erik builds artificial intelligence systems and teams. He was a researcher at Harvard Medical School. After that, he joined two unicorn startups, Invitae and Freenome. He co-founded Revel, a deep learning cancer screening company. In 2021, he founded Eventum AI, an ML consulting company. He manages a team of around 10 ML research engineers working for high-growth startups like Sonos, Playlabs, and DeepCell. His team has worked on voice cloning, large language models, stable diffusion, computer vision, financial time series, etc. Erik graduated from University of Arizona with 2 degrees, computer science and physiology. He also has 2 US patents. Erik taught himself to code when he was 12. And today we're going to talk about generative AI project he worked on, how he built production ML systems, and how to scale ML teams. Welcome to the show, Erik.
Thank you for the very wonderful intro, Daliana. It's my pleasure to be here.
So we hear a lot of buzz around GenAI and a lot of people think it's overhyped. And for a ML consultant working with a lot of startups, what's your take?
Well, I think that we are definitely in an unprecedented age of AI acceleration, both culturally and technologically. I think that there are certain areas where Gen AI might be overhyped. For example, a lot of people think that LLMs can completely automate away a lot of jobs that require a lot of cognitive reasoning. And I think we're at least not there yet, and it's unclear when that will come. Maybe it'll be a GPT-5 or 6, but it doesn't seem like current models are able to do that anytime soon. But there's lots of really exciting, consumer applications like chatbots and things like that provide a lot of entertainment for people. And I think we're just beginning to scratch the surface of what these large models can actually do. So it's quite exciting. I think there's a lot of uncertainty in how powerful the technology will become and how quickly it will become. But yeah, it's very exciting.
So what are some use cases you have worked on at Eventum AI?
Yeah, so we've worked on a bunch of different use cases. We worked, for example, with stable diffusion, creating a kind of generative AI version of Instagram, and that was with Playlabs, which has the same founders as MySpace, so very exciting team to work with. We've worked on building voice technology with Sonos. So they're doing real-time accent translation. So basically when you speak into it, you speak into a microphone, it runs it through a neural network, which removes your accent. So the other person hears, your voice or maybe someone else's voice, but with no accent, which makes it a lot more intelligible.
And is this in real time?
This is in real time, yes.
And what is the biggest challenge in this project?
There's a lot of challenges in the project. I think one, the technology doesn't really exist yet, so it's very research heavy. I think voice cloning in general has sort of only just started to work in a sense where it sounds natural. There's no real-time, like open source models out there, so you're very constrained in terms of, for example, the size of the model.
Can you tell us more about the Sonos project? What was the problem you're trying to solve and what was the solution you provided?
Yeah, so we've been working with them for a while. At first, we came in to help them specifically with their ML ops. So they were a research-heavy company trying to get their first initial model working. We came in and basically helped refactor a lot of their code to make it more modular, make it easier for the different scientists to do experiments within a single repository. So basically making parts of the architecture swappable and configurable. We set up a lot of standard DevOps things like continuous integration and deployment, so that way models were routinely tested on GPUs. We set up ETL using this tool called Daxter, which is similar to Airflow, which people might know, but sort of a newer kid on the block that we like a lot. And there was basically a very complex flow that would happen between their data scientists in terms of handing off different files and different code bases to run in order to generate their final model. And so we streamlined all of that through Daxter and all of the data ETL, all of the training of models, all of the serving of models and productionizing and things like that. So that allowed the data scientists to basically massively reduce the amount of time they're spending on these sorts of schedulable type tasks and really spend their time much more on the actual data science and model development.
Yeah. So when it comes to voice cloning and accent removal, what are the metrics you use to evaluate a model?
There are a bunch of metrics. So one thing that our science team did was establish a lot of new ones. It's a little bit of IP in terms of what metrics we actually use, but an example might be signal to noise ratio. So these are things that you can compute objectively, measure in TensorBoard and things like that. But we have a whole host of metrics that we established and compare every time that we also, it's generative AI. So the final say is always human. So there are human labelers, which will basically rate the quality of different audio samples. And we also have some automated ways to do that, which I can't go into details about, but it's quite interesting.
Cool. So how was the dynamic between data scientists, ML engineers, and the data labelers? How do they work together?
Generally, the data scientists will hand off data sets to the labelers. There are internal labelers that Sonus has, and they will take that data set, label it, and return the results. It's a pretty fast turnaround, and it's all done internally.
Yeah. And I will also imagine there might be data quality issues when it comes to voice data. So what are some challenges there?
Yeah, so that's another thing that we spent a lot of time on and helped them with. With any machine learning project, there's always data quality issues, and it's, you'll find almost impossible to spend enough time doing those data quality assessments, and it's not always the most fun thing to do. So one of the things that our science team did when we first started working with them is to do our own data quality assessment, figure out which files and parts of files we thought were bad, look at the overlap with the data quality assessment that their internal team had done, and figure out what the differences was. And we were able to uncover a lot of issues with them by having just a different set of eyes. And so that ended up making a pretty big difference.
Yeah. How much time would you say you spend on evaluating the data quality issues?
Well, a lot. And I would say that, we did some initially. We wish we had done more because we did some experiments and sort of uncovered things that were related to data quality, and then had to go back and do a much more thorough look at it. But certainly over 100 hours were spent just on data quality assessment.
Yeah.
It's quite hard. You have to listen to the files when you're establishing these metrics. Anything that falls out of the bounds, you have to spend time listening to and really assess that. So it's very time consuming.
Yeah. And when you evaluate a model, how do you know when it's good enough?
The final say is certainly done by humans. I think that, you can always aim for hitting certain metrics, but at the end of the day, all we can really do is try to make a model that's better than the last one.
Yeah. And when it comes to kind of audio data, what are some typical GenAI models or libraries you use? Are there any open source solutions you typically go to get a simple baseline?
There's not a lot of baselines for this type of work that we used. There's certainly a lot of open source libraries like Torch Audio and Vectorwave and things like that. So we certainly rely on and pull a lot from the open source community, but the model is pretty custom at this point. So
Yeah.
yeah.
And you also talked about evaluate the model across the same set of metrics to so you can compare different versions of model consistently. And if you have different ML engineers work on different models, did you build a internal tool to visualize the metrics?
We generally just use TensorBoard to visualize, and certainly after any experiment, we'll make a table and be able to compare, the last 15 experiments or the last week compared to whatever the baseline is, which is kind of the current production model.
Yeah. So there are a lot of MLOps tools out there today help you document the model versioning, look at the metrics. Do you use any of those? Do you feel it's overkill? Some simple documentation is good enough most of the time?
I lean heavily towards those things being over engineering for the most part. There are certain tools that we use like MLflow, but generally just find, putting things in a bucket and versioning it and labeling the files and including metadata is generally a lot simpler and more flexible than trying to rely on external library.
Yeah. And was there anything unexpected while you're working on this project?
There's certainly a lot of unexpected things. You never really know what's going to work, and you generally just have a lot of hypotheses and ideas, and you try to make one step in a direction towards success at a time and try a lot of things. Maybe 1 out of 4 of the things will work, and you step in that direction. You just keep iterating that way.
Yeah. So you also helped Playlabs build a viral social media app. Can you tell us more about that project?
Yeah, so I worked with Playlabs very early on. So very exciting company. It's founded by the same founders as MySpace. They also created this unicorn called Jam City, which was a mobile gaming company that they ran after MySpace. And they were very excited about what was happening in GenAI, and particularly right when Stable Diffusion came out, there was a lot of excitement around creating some sort of social media based app on Stable Diffusion. They are social guys. And so, it was kind of like this. It's one of their 2 main products out right now. They have that and a game called Champions. I wasn't involved with the Champions game, but with the Playday app, which is this kind of generative AI version of Instagram, I put together an initial team. I managed it for the first 6 months or so. And then they ended up hiring the team full time. But while I was working with them, we built a Stable Diffusion based backend, or at least my team was responsible for the backend from scratch, which involved a lot of fine tuning of Stable Diffusion using methods like Dream Booth, but we also extended it with custom research and methodologies to improve the results. So we could basically teach Stable Diffusion what users looked like, and in the app it would generate you in all sorts of different avatars and sort of scenes, sometimes even with friends and things like that, and your friends could comment on it and like it and share it and things like that.
Yeah.
Nowadays they're extending into other exciting technologies like text to video and face swapping, deepfake type things.
Yeah. So when you fine-tune Stable Diffusion models, what are some metrics you use? And also, because this is a social media app, they also have business metrics, maybe about engagement, how many people click. So how do you balance the online and offline metrics?
So I wasn't super involved with the sort of social metrics.
Okay.
So I don't have much insight into that. As far as the machine learning ones, we use a lot of classic measures like FID scores, which is like inception distance. So you kind of look at the activation values of an inception network on the generated image, and you look to see basically if those activations are within the same sort of embedding space is an ImageNet image, and that tells you if it's producing kind of like a realistic image. So pretty standard metric that comes from just image generation from the GAN era.
Yeah.
But we also developed an internal tool for people to do very quick voting to compare the results of two different models, which was pretty important. So we definitely had to have those human annotators. And we used some other sort of more specific metrics to this project, like facial recognition measures. So we wanted to make sure that the images coming out looked like
Human?
not just a human, but the person, the user.
Oh, right. Yeah. And how often do you sample inference to see whether it works well? Do the labeler check everything, or they have some sampling techniques?
I think we did 20 images each time we wanted to compare a new model.
Yeah.
Yeah.
And so it's interesting you helped them build this project and then they hired the team. Is this common from your experience when people hire consultants?
Yeah, so different agencies offer different sort of services. Oftentimes, they don't really want that, but I think specifically when I went into this project, that was their interest, and that's the way that I've worked with other clients as well. It's like the consult to hire model. It allows them to trial without having to take on a big risk by paying large recruiting fees, the people that they're hiring. I think that's generally been a pretty great model for people. Agencies might not like it because they don't want to lose their best people. It can be very hard to find them and vet them. But it worked out great for this project. And I think we're probably leaning more towards the less full-time hiring, at least with the bigger projects. But we're definitely still open to that sort of thing.
Yeah. So if someone's interested in building a machine learning product or GenAI product and want to work with you, how do they find you?
Yeah, so we have a website, eventum.ai, and you can just go on there. You can find out more information, see some of our case studies, and there's just a form out there you can fill and have a chat with me.
Yeah, I'll link the form in the podcast as well. So,
Thank you.
What are some other projects you worked on recently related to GenAI?
Yeah, so another really cool project that I worked on was with this company called DeepCell. So they are making a microfluidics device which sorts biological cells. You put in biological cells and basically runs it through a small tube, single file, and there's a camera taking pictures of the cells, and it sends the image to a neural net, and the neural net says, this is a stomach cell, or this is a skin cell, or this cell looks cancerous. And it uses that neural net classification to send it down a particular path. And at the end, you have chambers of sorted cells. So very exciting company, modern technology to do cell sorting, uses fluorescent labeling with antibodies. So they basically put these proteins into the solution where the cells are, and they'll bind. And if they bind, they'll fluoresce. And only certain cell types will bind. The problem with that is when that happens, it changes the internal state of the cell because it's interacting with all of these molecules, and it changes, for example, the genes that are turned on or off. And that's often what biologists want to study. So by using cameras, they're able to sort of do this in a way that doesn't modify the cell. So very exciting technology. When they hired me, they basically brought me in to rewrite their entire pipeline. This is actually something that I did personally. So I took them from some sort of crufty, older TensorFlow code, redid it in PyTorch. I used things like PyTorch Lightning. I also integrated self-supervised learning, which is, everybody sort of is much more familiar with that now that LLMs have taken off, but LLMs, are trained using self-supervised learning where you don't have humans labeling things. The labels are in the data itself because you're just predicting the next token. The same thing can be done with computer vision. And there is, this was a few years ago, but there was research coming out at the time that was, very fresh, showing that this was possible. Sort of naively, you would think that you would want to just mask out a part of the image and then predict the mask part. But that doesn't really work. People kind of hypothesize that it's because the dimensionality of images is just too high. If you block out a square, there's just too many possible things that you can put there. And so the network just learns kind of average of all possibilities rather than a really good one. Unlike in language, when you're predicting the next token, there's a very limited vocabulary set of tokens that you can predict. So basically, this came from LeCun. What he showed was that there's a pretty landmark paper. If you take a neural network, it's kind of like a Siamese network where you run two different images through the same network. You can think of it as two networks, but with shared weights. But you augment the images, but with different augmentations. You run that through the network and it embeds it into a vector. You embed these two augmented images, but you want to embed them into basically the same coordinate space or almost identical coordinates, because the semantic information in the image should be the same when you augment it. So if you rotate it a little bit or change it to a black and white picture, you still want it to go to the same coordinate or embed to the same coordinate, because what you care about is like what's actually in the image. Like there's a chair in the image, or there's, a man in the image, or, Daliana's in the image.
Yeah.
And so that ends up being this really nice self-supervised learning objective where you can take basically all of ImageNet without any of the labels, run it through this process, and then you can take those embeddings now. So you have this embedder, and you can basically just through vanilla logistic regression estimate or learn all of the classes of ImageNet with an accuracy. At that time, it was 70%, but it's like climbed up to the high 90%. And you only need maybe like 2% of the labels. So if it's very similar to large language models, where you can just download all images off the internet, train this incredible embedder which understands vision space, and then you can take just a small amount of data, like 10 examples of a class, and create a very simple classifier with just one linear layer logistic regression, which just cuts down on the amount of labels that you have to do.
Right.
But also this embedder is just this, it's kind of like it's visually generally intelligent. It just understands vision space.
Yeah. And you said you improved the accuracy after you use self-supervised.
So self-supervised learning helped the most with reducing labels and making the embedding space a lot more useful. So for example, when you clustered off of the embedding space, which is done often in biology, you want the images of cells to cluster by their actual biological type without using any labels. So just with unsupervised clustering. So that was one huge benefit. And another was in just massively reducing the amount of labeling that people had to do.
Right. And does this project have a class imbalance issue that you had to deal with?
Yeah. So there were definitely class imbalance issues. There were rare cells. We had to address for that through all sorts of different techniques,
For example,
weights and the loss. So you can, weigh the underrepresented classes higher. You can oversample those. You can undersample.
Yeah.
The overrepresented classes. You can augment the underrepresented classes more often and things like that.
Yeah. I've seen a lot of debate around oversampling, and a lot of people say SMOT never really worked. What kind of oversampling techniques you usually use?
I usually find that you have to have heavy augmentations if you're doing oversampling. So it's very dependent on that. You can't just oversample the same image or the same data set. You have to minimally add noise, but ideally add something that's more specific to the data type.
Yeah.
So for example, in cells, it doesn't really matter if the cell is rotating, right? So that's like a very good augmentation to add, because you want to be very invariant to that. And you can do things like smooth the image and things like that. But Yeah, generally just loss weighting works the best,
Cool.
but it can be very problem dependent.
Yeah. So you used to work at Harvard Medical School. Was your background in biology helped with your domain knowledge in this project?
With Deep Cell, it did somewhat for sure. I was able to sort of get a sense, certainly on the product side, what was important. They were doing a lot of DNA sequencing, for example, of the cells, and that was an important method for assessing how well the sorting works. You want to like sequence those cells and make sure you're getting DNA from the types of cells that you expect. I think that also in general, doing a lot of science is like very transferable. So, I did a lot of data science on biological data.
Yeah.
There are very specific things that you have to look out for in the biological domain that aren't as that either don't exist or aren't nearly as big of a problem in other data sets. An example of that is basically what's called a batch effect. And this is something that a lot of pure machine learning people who go into bio like completely miss and might even spend like years thinking that they have results that aren't necessarily true. And so basically what a batch effect is, it's a bunch of confounding information that gets put in your data that comes from the lab. So an example would be if you have two DNA sequencers and you put all your cancer samples on DNA sequencer A and DNA sequencer B, and you sequence the data, you pre-process it, you run it through a machine learning classifier to detect which is cancer and which is healthy. It's easier for the machine learning to pick up on which sequencer the sample came from rather than any biological signal, because the sequencer has its own sort of like fingerprint on how it reads the data. Not all laboratory equipment is, identical.
Yeah.
And so that's an example of a batch effect. The like maybe it's one sequencer, but all the cancer samples were processed, 1 week, and then all the healthy samples were processed another week. And in the first week, it was a different operator that used a slightly different level of reagents during the pre-process, the like physical pre-processing of the samples.
Yeah.
And so you have to be really careful about that. It's very hard to disambiguate that if the experiment wasn't run correctly. And in some cases, it's actually impossible.
Yeah. And so you have a lot of experience scaling machine learning teams. So can you tell us what is your strategy scaling the team, say from 1 to 10? How do you know who to hire? Because in machine learning project, there are a lot of uncertainty. Sometimes the project fail.
Yeah, it really, I think, is project dependent. If it's a research heavy project and you need to figure out things that haven't been done before, then you really need to just hire researchers. If you are using open source methods, trying to take what's being put into the open source community and sort of make applications on top of that, then you need much more engineering heavy people. I think generally you want like a pretty core team of machine learning engineers, which are kind of the jack of all trades types who can read papers and reproduce them, but also can do production software engineering. I think you want to be pretty careful about going too heavy into the pure research hiring direction, because a lot of times they will, if left to their own devices, write code and systems that accrue a lot of technical debt. So that's something that, for example, we've had to come in and clean up, and it's not very fun. Scientists won't take the time to set up things like continuous integration and deployment, so they won't have unit tests. They'll have weird structures in their code. Well, they'll have 100 branches, all with different experiments, rather than working on a single code base that has composable configuration and swappable components. And yeah, so it really depends on the project, but generally you can sort of lump people into three categories. There's the scientist researcher, the machine learning engineer, and then the ML ops or DevOps type person. And by default, there should be probably a pretty even distribution of those But depending on the business needs, you might want to focus on one over the other.
So, do you think the researchers or data scientists should spend more time writing code, learning the ML ops, dev ops, or you think people should focus on what they're good at?
I think that there's a certain level of software engineering that at least I require of people. They should be able to not just work in isolation. And there's a certain level of software engineering required to do that. Like you need to understand Git. You should be able to write unit tests for your code. You should be able to document things. It should be very easy for someone else to understand your code without you having to handhold them and things like that.
Yeah.
So I think that there's a floor on what that is, but past that, it becomes not useful if you can afford to hire ML ops and ML engineering people because it's quite a big cognitive load to do experiments and data science all day. And the more you can specialize, the better you can be at that. But I think what I've seen is that people, for example, who only operate in notebooks need to work at big companies where they have a ton of support for that. And that's generally not a startup.
So if you work for a startup, you need to have more full stack ML engineer or data science skills.
That's right. Yeah.
And when you are hiring someone, what do you look at? How do you evaluate talent?
Yeah. So there's generally, a process that we go through. Currently, oftentimes I will meet with a person, ask them about a project, just get a general sense of whether they can dig into the details of something that they've done before. I might ask some sort of technical question just to get a baseline assessment of whether they know some sort of fundamental concept or architecture in machine learning, just so that they don't waste our time, basically. I think once that's done, then we put people through a pretty rigorous technical interview that involves machine learning theory, machine learning practice, which I think can be very different in terms of what you ask, and also software engineering.
Do you ask them lead code questions or you ask them to code like a back prop?
It really depends on who's interviewing them. So I leave it up to the team. Sometimes people do, I would say usually more like lead code type questions to assess how well you can do software. Sometimes we also do homework if it's sort of like a full-time hire type of deal for a big position. But yeah.
Yeah. And say if there's someone who is very strong in research and data science, but not very good at the engineering side, would you hire this person?
It really depends on the team. Yeah, if they don't have the support, then they're just not going to be very effective.
Yeah.
Particularly, also depends on their personality. Some people are actually quite excited to learn software, and generally people who can do data science really well or do model development really well can learn the software engineering.
Yeah.
They just usually don't want to. So
Yeah. And so you worked in research before, and now most of the project you worked on are in production. So what's the difference between research and production?
yeah, so I would say my entire career was in this research engineering where it wasn't pure research, where you work on something for 4 years or something, you're not sure if it's going to work. Generally, there is a pretty high chance of success, but it's something that hasn't really been done before. And that's kind of my sweet spot. So, when I was at Harvard, the research that was more about like publishing papers and ideas and things like that. But even there, the project that I worked on that was most exciting was working with a group to sequence one of the first clinical genomes and interpret it in a clinical context. And that just, had a very clear end outcome. And we knew it was possible. It was just very expensive and required a lot of experts. Throughout, even a lot of the projects now, not all of them are still in that category. So I think the voice stuff, for example, is like research engineering where you're trying to build something that you don't know exists, but it's, just kind of pushing the boundaries of what's possible now. And so there's very high confidence that it's doable with a good team. And, oftentimes those can lead to publications and papers, but it's not necessarily about always developing some new fancy idea. It's more like, here's something like really new and cool that we built.
So it sounds like you have worked on a lot of very exciting GenAI projects, especially help those high growth startups grow. Are you open for new projects?
Yeah, we're definitely taking on new projects. Our team is growing very rapidly, and we're really excited to push the boundaries of what can be built. We're happy to talk to people who have a project funded, and maybe you can just drop a link for a form into your show notes, and people can fill it out. And yeah, would be happy to chat with them.
Sounds good. Are you focusing more on GenAI projects or traditional machine learning, deep learning projects, or anything related to ML?
Basically anything related to ML. I think that GenAI stuff is certainly the most exciting, but I think no one truly knows what can or can't be built right now. So yeah, we're excited to work in basically anything in machine learning.
Yeah. So now with large language models and GenAI, what do you think about the future of machine learning?
It's very exciting. I think there's a lot of uncertainty in predicting anything in the future, but with the amount of money and minds that are going into this, I think that we're going to most likely evolve at an unprecedented rate in terms of technological advancement. I think that, a year ago, not many people were aware of AI and what was happening. It was just small group of friends. A lot of my friends thought I was crazy for being so obsessed with it, but and always wanted to talk about it pre ChatGPT, but post ChatGPT, it's sort of, at least in the Bay Area, what everyone's talking about these days. So yeah, I think that there's a possibility of AGI coming in 10 years or something like that, which
10 years?
yeah, I think it's totally within the realm of possibility. Nobody really knows, of course, but the rate at which it's improving is pretty astronomical. I think if you look at, for example, what was possible last year compared to what's possible this year, what was possible 2 years ago compared to what was possible 1 year ago, it's pretty mind-blowing.
Do you think the growth will be at the same speed of, compared last year to this year? Are they only going to grow in an exponential way from now on?
Yeah, well, I mean, the big idea that we have right now is scaling LLMs, and that kind of is the only thing that's working, or scaling transformers at least. There's ancillary ideas being pursued, like multimodal transformers, which is quite exciting, and things like agents, but it's very unclear sort of if agents will start working anytime soon. But what is clear is that if you throw more compute and more data into a transformer, it gets, kind of objectively more intelligent, and it can accomplish new tasks, and new capabilities will sort of just emerge at certain sizes of models. And so, we're certainly throwing a lot more compute at these models. OpenAI just, got more than $10 billion, and they're spending a lot of it on GPUs.
Yeah.
And I think people are, a lot of people think we're out of data, and, they've gone through everything, all the text data on the web, but I think there's a lot of ways to imagine getting more data. So, for example, it could be synthetic. It could be in other modalities, like consuming all music, consuming, all the videos on YouTube. That's
Factory? Do you think that would be possible?
olfactory. I don't know if we'll make I mean, it's definitely possible. I don't know how olfactory electronic sensors work, or how well they work, but could probably collect data for that. And there's a lot of like really interesting research that shows, regardless of what modality you're learning in, transformers are learning sort of universal computational rules and capabilities that even if you don't change those parts of the transformer, it can still do intelligent computation on other types of modalities. As long as you put those modalities, you learn sort of like a adapter that puts that other modality into the same space.
Yeah. It's interesting to talk about synthetic data, and also more and more people are debugging their code in ChatGPT. There are fewer inputs in Stack Overflow. And do you think, say, if we're using public data to train some kind of coding LLMs, will synthetic data be good enough? Will this be a problem?
I think that my guess is that synthetic data will be incredibly useful. You could imagine, for example, making perfect examples of math and, teaching or feeding it tons and tons of examples of not just algebra, but calculus and
Yeah.
things like that until it becomes really good at that. And as far as coding goes, I mean, I think we've consumed most of what's publicly available on GitHub, but there's a lot of research in teaching large language models to write not just snippets of code, but synthesize entire programs. And so once they're doing that, I think there's very likely going to be these self-improving loops that don't require data that emerge. Examples of that are, reinforcement learning self-play, where you can make super intelligent chess playing or go playing agents without having any data. And we started out by having them learn from databases of expert players, and we ended with them just playing each other, making random moves, and learning from there. So you can imagine, something like LLMs dueling each other, and learning from each other and things like that, which I think is important for how humans learn as well.
Yeah.
I think it's, yeah.
And there's also a lot of blog posts generated by large language models, and some of them may have hallucinated facts. And then those might later be used as training data in large language models. And what do you think about the future data quality for training generative models?
Yeah, I think that data quality is really important. My guess is that not a lot of like blog posts are going into these models. I also think that the future of large language models isn't going to necessarily include trying to compress all knowledge into the weights of the network. And they'll have some general knowledge of the world, much like a human, but what's really important to encode into them is their ability to do cognitive reasoning. And so when they need to find out a fact, they'll go on the internet or access a database of information and retrieve that and then present that information. So
Yeah.
I think it's likely that's going to be the future, but it'll be interesting to see what plays out.
Do you think in order to train large language models for cognitive functions, we need to give them some philosophy books to read?
That's interesting. Yeah, philosophy certainly requires a lot of reasoning. Um, I think like mathematics is another example of that. Being able to solve like kind of word puzzles
Yeah.
or maybe even spatial puzzles. I think that multimodal models this might just kind of emerge out of them because you have to be able to do good reasoning to think about the physical space and, predict what's going to happen as objects interact with each other.
Yeah. Yeah. And how do we teach large language models empathy? Do you think that would be important?
Yeah, I think actually that seems to be something they're already getting pretty good at in some sense. Like if you talk to some of these large language models, I would say they're frighteningly good sometimes
Yeah.
at being able to help you work through some sort of difficult emotion or a situation that you're dealing with involving other people. Whether it can feel what you're feeling, I don't think that, might I don't think that concept will really exist because artificial intelligence is, pretty alien. It's as
Yeah.
alien of a mind as like I think like a true alien would be. But it will be able to sort of simulate what people are feeling and use that information to, hopefully help them.
So you read a lot of research papers. What are something you're currently obsessed with?
I'm very curious about these sort of self-learning loops that I was mentioning to you, where you can make self-improving systems that aren't data dependent. So, an example of that is a paper that came out recently, which was using large language models to describe in text a reward function for reinforcement learning. And I think that that's a really promising, exciting area. One of the sort of reinforcement learning has gone into vogue, but I think people are trying to merge LLMs and reinforcement learning. And one of the limitations of reinforcement learning, the biggest limitations is the credit assignment problem.
Yeah.
Where you see a reward in the future for an action that you took a long time ago. And it's really hard to know what that action is.
Yeah.
I think as humans, we can simulate in our mind and go back and think, okay, like I got this reward. If I go back and think about the actions that I took, if I didn't take one of those actions, would I still have gotten this reward? And that's a counterfactual. And that's if you have a good world model, you can attribute that reward to that action because that was the causative action. Had you not done that, then you wouldn't have received the reward. But you need a really good world model and understanding of the world and be able to simulate it to do something like that.
Yeah.
Large language models might help with some of that as well by sort of being able to like write out complex rewards in natural language that have sub goals and things like that, much like how we have to give ourselves sub goals in order to get to a larger goal, and also describe more abstract goals. So you could imagine, how do you make a reward function for backflipping? It's really hard to do that in Python.
Right.
But you can describe what a backflip is in language.
Yeah.
And so if you have a multimodal model that can look at the image and assess in language whether it's doing that backflip, then you could reward that agent in a very non-sparse way and give it really good signals so it can learn quickly. It's kind of like when you have a kid, you're like, good job.
Yeah.
And you keep saying good job over and over again for this kind of abstract concept. That's,
Right.
I think, an important way for them to learn.
Yeah, it's just like when you use ChatGPT, you give them identity. You are an senior data scientist, and people are joking you're just gaslighting LLMs. So for the things you said you're interested in, have you seen any applications or are you building any side projects using the research papers you read?
AGI stuff, I think, is more just for my own personal interests. It's very rare for, startups to want to hire you to do that kind of work.
Yeah.
But, there are research papers, for example, in voice or model distillation and things like that, which we apply to our clients.
Yeah. And so there are so many new papers and new, blog posts out there every day. How do you keep up? How do you decide what to learn? And also when it comes to a project, when there is a deadline, how do you, quickly learn something new?
Yeah, so there is a crazy amount of papers. It's an information. It's definitely exponentially increasing. I definitely subscribe to a few blogs. Yours is one of them. I also like The Sequence and Ben's Bytes, which kind of allows me to see what's going on and see at least I can get the big papers that are making a splash and, the companies that are raising and the new products that are coming out and things like that. So I probably spend maybe an hour just kind of reading that high level stuff. And if something piques my interest, then I'll spend time reading it. For projects, it'll be much more tailored towards whatever the objective is. If it's, we need to improve someone's distillation process, then I'll do like a probably with the entire team, a literature review. People we'll figure out the papers that we want to dive into. People will dive into a specific one, and then we'll come back and people will kind of teach each other what they've learned. And then we'll make a decision on experiments to run based on that.
Cool. And when I told my audience I was going to interview you on talking about GenAI projects, a lot of people have questions. Curious, what are your take on those? For example, people are debating, do you think in the future the OpenAI or Anthropic, those large language model will be dominating in the production world, or do you think the future is open source, or is going to be a kind of combined use case?
Yeah, I think it'll be combined. I think the closed source models will always be the first thing that people try because they're just more generally intelligent. And so they'll give a pretty good go at, at your problem when you're first trying out. People will generally switch over to open source as a means of becoming more efficient and reducing costs. If you have a specialized model, it's smaller, cheaper to run inference and things like that. There's also use cases where you want access to the model. For example, if you want to look at the activations or the logits and things like that to do custom, maybe you want to train another classifier on top of it, and you want to just like hook it up to some of the last layers. You might want to use open source models if you want to also, do research and things like that. Maybe you want to do some new special fine-tuning process.
Right. For your private data.
For your private data, yes. A lot of people just won't want to send their data to the big companies, but they're always going to probably lag at least, 1 or 2 years behind the big models. And the big models, 1 or 2 years is a lot of time in the current state of things. Like the difference between GPT-4 and GPT 3.5 is like a big set of applications. GPT 3.5, which is, kind of where open source is at these days. And so you have to use the bigger models.
Right. And do you think in the future there will be a lot of large language models that works very well for specific use cases? So we just do RAGs instead of fine tuning, because there are also a lot of tools today focusing on helping you fine tuning. So what do you think about those use cases?
Yeah, I think every actual application is likely going to use both. You kind of always want to start with RAG because it's easier. You can accomplish a lot of the same things as fine tuning does by just pulling in examples from the data. So, for example, if you're asking the large language model to classify something in the text or, convert text to SQL or something like that, giving it examples where it had performed that correctly in the prompt and saying, here are examples of how to do this correctly. Now, please do the same thing, but with this context, it dramatically improves, which is basically what you're trying to do with fine tuning for most of the time. So that's just a lot easier and cheaper to implement, and still will help if you fine tune the model.
Yeah.
But then, fine tuning adds its own advantages, but it's expensive. It takes a lot more machine learning expertise. So, in any actual production grade system, what you should be doing is spending a bunch of time setting up an evaluation framework, coming up with metrics. You gather your data set, you develop RAG. What I was describing before is that you provide some K-shot examples of successes and failures, and then you start fine tuning it, and then you just try to improve your metrics.
Yeah. Cool. So you started your career as a researcher and then joined startups. Now you started very successful consulting business. So looking back at your career, what were some important lessons you learned or some mistakes you made?
Yeah, I think there are a lot of, when I was younger, especially my first jobs, I really just wanted to do interesting like model development work, which is very common, right? And I definitely missed some career opportunities to move into management at a younger age.
Yeah.
And there's some upsides and downsides to that, but there were some points in my career, for example, when I did my first startup where like people and investors, for example, like care about those sorts of things. And there's a lot of clout that comes with being a manager at like a publicly traded company, which is something that I
Yeah.
had turned down because I just, wanted to spend more time actually modeling and things like that. But I also learned a lot doing that. I think, some other big lessons that I learned were with the first venture-backed startup. I think I jumped into that very quickly, and there's just a whole host of startup lessons that you learn in terms of how to build the team initially and do the study and deal with co-founder issues and hiring the right people and negotiation and things like that. I think I probably under negotiated in my early career. I just kind of didn't care, wanted to do interesting, exciting work, and
Yeah.
maybe left some things on the table there. But yeah.
And how did you learn those people management, negotiation, kind of quote unquote business skills later?
Yeah, I really only learned those much later in my career. And I think it's like just getting reps in is the most important thing. I hadn't interviewed very much in my early career. I was sort of like on this trajectory and doing genetic diagnostics and research. And then I did that in industry. So I really kind of knew where I wanted to go. But once I moved into consulting, taking a lot of sales calls, doing a lot of negotiation and things like
Right.
that. And you just sort of, it's nearly impossible to replace that experience. So, for listeners who are maybe data scientists, I think just getting reps in interviewing is really hard to replace.
Yeah. Yeah. And so you started coding when you were 12.
I did, yes. I think it's maybe a somewhat common experience where I played a lot of video games when I was young. And then I started like making like fan sites. So I learned HTML and it was at the time StarCraft. And I started writing these strategies and like build orders. And I ended up getting, a decent amount of traffic. There's like 1,000 people coming to my website, which when I was 11, that was pretty cool.
Yeah.
And I put a banner ad up and I made like $20. And I thought that was the coolest thing ever. So
Yeah.
it just like sparked this thing in me where I was like, oh, I can make money on the internet. And so I just stopped gaming for the most part and just worked on my website and then realized that I could build a Unix web hosting company because I was learning Unix. And then in order to get clients, I started coding to create this kind of control panel for them to add email addresses and subdomains and MySQL databases and things like that. So I wouldn't necessarily have to.
Yeah. And later, how did you get into machine learning?
So I got exposed to it when I was at Harvard. It was one of the projects there with the autism data set and trying to basically reduce the number of questions that we had to ask people. And it was very interesting. I, in my early career, was much more excited about sort of probabilistic statistical method, like probabilistic graphical models and Bayesian methods. That was what was actually effective in working at the time, especially in medical diagnostics, where you had to be very calibrated in your probabilities. You can really make mistakes, or people would get the wrong surgery and things like that. So there's almost no one using the sort of black box machine learning methods back then in diagnostics. But, it was still called machine learning at that time. It was just, and it was actually called generative machine learning.
Oh.
Generative was at the time, there's like generative and discriminative machine learning is like the black box type stuff that
Gotcha.
has gotten really popular.
Yeah.
And generative machine learning is generated by probabilistic functions or distributions.
Right.
And those are like the methods that I was using. So things like hidden Markov models, where you really like write out the generative probabilistic functions that are generating your data, and then you do inference, fit the parameters of those distributions, and things like that.
Yeah. I remember I was Googling generative models. I think linear regression also came up. Technically, it is generative model. But it's different from the GenAI we talk about today. It's more sophisticated.
Yeah. Yeah. I think also, I mean, the sort of like big moment when I switched into neural networks was in 2017.
Mm-hmm.
And that's when I saw this paper come out, which basically completely crushed the methodology that I was using, hidden Markov models, for determining what nucleotide DNA bases were going through a type of DNA sequencer called nanopore sequencing. So basically, you have like a piece of DNA running through this small nanopore, and there's electricity running through it, and the voltage changes depending on the nucleotide. And the goal of the model is to determine like what is the sequence. And the methods that I was using were hidden Markov models, which is state of the art. And then someone was like, and it takes forever to build these things. Like you have to like really like write out all the math.
Yeah.
And it's very constrained because like anything nonlinear is kind of impossible to describe. And then someone was just like, hey, if you just run this data through an LSTM, it's like 20% better. And I was just like, what's going on here? And then I just went really deep into what was happening and decided to just completely switch over to neural nets at that point.
Yeah. So what are you excited about your career in the next couple of months?
Yeah, I'm excited to continue helping different startups and companies build their ML technology and teams. And, every day is kind of, there's just a lot of excitement about what's coming out in research. I think, one of the labs are just any day now going to release something that just blows everyone's minds. And, we might not be like a chat GPT moment, but, I think something's going to happen.
Right. Maybe by the time we release this episode, everything we talked about is obsolete.
Yeah, maybe.
So what are some of your passions and hobbies when you're not reading papers or work on ML consulting?
Yeah, I like to get into different forms of movement. I kind of have a similar philosophy to movement as, machine intelligence, which is I really like hone in on general movement. So I try to be a very generalist and explore lots of different forms of movement and not specialize in any one thing. So that might take the form of weight training or running or dancing or rollerblading or juggling or something like that.
Cool. Before we wrap up, anything else you want to share with our audience?
Yeah, I don't know. I think this is just, again, like really exciting time to be in machine learning. I, definitely no longer feel like this weird outcast guy who's obsessed with it, and it makes sense to people. So
yeah, it's cool to be a nerd.
Yeah, it's very cool to be a machine learning nerd.
Yeah.
And there's just so much happening in San Francisco. There's events, 10 events every night, 10 hackathons every weekend, and tons of different venture capitalists starting their funds or getting funded, and lots of companies spawning. So it's all very exciting.
Yeah. Do you feel overwhelmed?
Sometimes, yeah, it's hard to keep track of everything, but at the end of the day, I think artificial intelligence is going to be this really great transformative thing for the world, and it's going to just create massive amounts of opportunity and abundance. So I'm really excited for that future.
Yeah. Well, thank you so much for coming to the show, Erik. I learned a lot about generative AI and your career, and I will link your company's form in the show notes and reach out if you want to work with him.
Thank you.